So this is problem 3 from the chapter 3 homework. So on the block diagram, we have a for loop, and we start, so we're given n equal to 300, so we'll run 300 times. And over here, we're taking our iteration value, and essentially this is gonna, by times it by 6 pi, which is our range, and divided by 300, which is how many data points we want. It's gonna turn that number into radians that we can send down here. And this, all this is basically the formula it gave us with the signs. So comes down, this is the normal sine x, obviously it just goes in. This is the sine of 3x times 1/3, so we have 3 times the value of x, and that runs into the sine function, and then divide by 3. And this is the 1/5 times sine of 5x, so same thing. The value for x comes down, multiply it by 5, put in the sine function, then divide by 5. And we come up here, and this is a compound arithmetic, so essentially it's just adding all of these values that we just got from the 3 sine functions. And up here, all this is times by 4 pi in the formula, so that's what we're doing here, is just 4 over pi times the value we got from the compound arithmetic, and we pipe it out into the waveform graph. And if we run it, we will get the graph that's from the book. Waveform, the block, okay. Now, this is problem 5, the drag in the dresser. And so if we come over here, another for loop, it wanted us to run from 0 to 90 degrees, so we have 90 wired into n, so it'll run 90 times. And so down here, we're using the I for our degrees, and so we're using also the degrees to radians function, so we send the I into a converter, which makes it into a double, because that's what this needs to read. It turns it from degrees to radians, and then this is kind of just the formula here. It goes into cosine and sine, and the sine also gets multiplied by our coefficient of kinetic friction, which is a numeric control, which we can control from over here. The cosine and the sine value get added, and then we have the coefficient of kinetic friction over all this added up, which is just the formula, like I said, and then we pipe it out into the waveform graph. And I already have the value for 0.1 pulled up, and we can see minimum force is like around a 20-degree angle, but it really doesn't change much until about 60, so you have a lot of room to work with. But it asks us to look at when the coefficient is equal to 0.1, which is why I have this one, and also 0.4, so we'll change that. Oh, need to run it. And so we run it, and we see the graph changes, and now it's more prominent that the lowest force required is going to be at an angle of 20. And then if we change it to 1, we see that it changes again, but now the minimum force required is, it's about 40 degrees, a little bit over, but we can really just say 40 degrees here. And yeah, that is my problem 3 and 5. Here it is one more time.